Hi everyone, thanks for joining us today for Disposable Jenkins as part of our webinar series this week. I just want to let everyone know a few things at the very top. So one, we are recording this, so the recording will be made available to everyone later in the week after the series has concluded. We are able to answer questions at the end of the session today. So there is a little question panel. Please make sure that you ask them as you think of them. Don't worry about if you think we may not be able to get to it or anything, because I can take them offline and we can get back to you later. Just want to let everyone know, make sure that you can all hear me correctly. If you can in the chat or the questions, please just let me know your name and where you're watching from. It'd be great to see where everyone is chiming in from. And then what I'm about to do in the chat window is put some text you can put into Twitter, and the first 5 people to send it out are going to be winning a t-shirt as long as you haven't won one on another part of the series already. So I'm going to give it a second, make sure everyone's ready and they're not being caught by surprise. And I'm going to put it in here, make sure that hashtag is intact so we can monitor it right now. All right, great. So we do have a lot to go over. This has been a really great session that happened at Jenkins World, and I'm really glad that Mandy's here to do this again. So first, just everyone know my colleague Andrew Bayer, who is an evangelist and longtime member of the Jenkins community, is on to watch the questions come in. If you see him replying to you or you see his name, he's here to just make sure that we get to some questions later. But for the sake of getting going, I'd like to just pass this right over to our presenter. So Mandy, thank you for joining us, and here you go.
Thanks, Max. So can everyone hear me okay? You guys hear me, Max?
We can hear you great.
Great, great. So as Max said, I'm Mandy Hubbard. I'm really excited to be here doing this webinar for you today, and I'm going to be sharing a unique Jenkins solution that I developed to build containerized microservices. Engineering teams use Jenkins to build and deploy software every day, and Jenkins is a critical part of an organization's success. I'm guessing since you guys took the time to join us for this webinar today, that Jenkins is an important part of your organization. So most engineering teams find Jenkins to be indispensable. Let me take a moment and paint a picture for you. Imagine it's 4:30 on a Friday and you have a major release on Monday when your Jenkins server goes down.
Yeah, Mandy,
It doesn't really matter. Yeah.
Are you still on the first slide, or are you still paused?
I am still in the first slide.
All right, great. Sorry, go on.
You know what? Here, that way you know I'm moving forward. You're right. I can move forward now. So let's go back and paint that picture for you guys. 4:30 on a Friday, and you have a major release when your Jenkins server dies. It doesn't really matter what happened. It could be a hardware failure, a fat finger accident, the zombie apocalypse, whatever. You've got a release and you don't have a Jenkins server. Take a minute and think about how long it took to perfect your pipelines and your jobs, your plugins and your credential sets. Hopefully you have a recent backup of your Jenkins home directory, but you know you're still going to work all weekend with IT to procure a new server, install Jenkins, restore your backup, regression test the Jenkins server just so your developers can pick up on Monday where they left off on Friday when your Jenkins server crashed. So I'm guessing this has either happened to some of you or maybe it's your worst nightmare, because it's definitely my worst nightmare. Well, guess what? With the solution I'm going to demonstrate for you today, Jenkins is indispensable and completely disposable. It really has to be, because it's just too important not to be. And I know that seems contradictory, indispensable and disposable, but I'm about to show you that it's not, and it's the best way to maximize Jenkins in your organization. So I built this solution for a company that provided payroll and tax calculations, and we're subject to a lot of the same regulations as financial institutions, such as SOX compliance and PCI compliance. So they needed a solution for delivering their services that was rock solid. I joined a team that was tasked with 2 things: for migrating a monolithic application into containerized microservices and to transform what had been seen as a traditional IT department, cost center, into a world-class leading-edge engineering team that could help the company move its business to the next level. So the first thing I knew we needed was a reliable, continuous delivery pipeline. And for this, I chose Jenkins. So this leads to why Jenkins and this solution is important to me. I've spent over 15 years of my career leading software QA teams and being held accountable for the quality of the software that was released. I also spent a year and a half as a support engineer. This absolutely confirmed for me that I would much rather work to ensure quality before the software is released than to deal with poor quality after it's in the hands of the customer. I'm here today because I care about quality. But what does that really mean? More specifically, what does it mean for those of us who are responsible for ensuring that the code we build runs in the way it was intended? For me, as a QA professional, quality is the ability to release software in a reliable manner that reduces the risk of regressions. I want engineering teams to think about quality when defining processes and not just in testing the end product, not waiting until the end of a release cycle to find out that we have a million merge conflicts to resolve. That's continuous integration. The next level is continuous delivery, which I'll show you soon in a demo. And every business cares about quality. Why? Because quality is what allows the business to move fast. I'm sure many of you have heard the old adage, why do cars have brakes? So they can go fast. Without brakes, the only way to stop the car would be to coast to a stop, meaning that the car could never go full throttle and still be able to stop reliably. Likewise, it's by building quality into the software and following processes with built-in quality checks that allows developers to confidently deliver software quickly. This lets the business move at lightning speeds right up against the edge of safety. Fortunately, releasing quality software is simple, right? It really is. Developers commit code regularly, preferably multiple times a day, to a main shared line branch. This is going to prevent that end of cycle merge conflict issue. Every commit triggers an automated build and test, and the code is only merged into the shared main line of all the qualities checks. That's all you need to do, define a well-defined process and have some discipline. The main problem with this is that it requires developers to be disciplined, and developers are humans. We all make mistakes, and we also may feel tempted to cut corners in our well-defined process when we're struggling to meet deadlines. The good news is that with Jenkins, we can automate not just the building of our software, but the entire end-to-end release process so that minimal human intervention is required. Developers love that they don't have to worry about how the software gets released, and they can focus their energy on what they do best, which is writing the code. So I'm going to talk you through what this looks like conceptually, and then I'll show you in a live demo what this looks like in practice. So many teams use GitHub as their source control management system. A team that uses GitHub typically has an upstream organization account. This would be the company account for which you work. In my example, it's called Dev Mandy. Individual developers on your team will then have their own GitHub accounts. When I, as a developer, want to begin work on a particular repository, the first thing I'm going to do is fork it from my organization's account. This essentially makes a copy of the repository at the time and brings it into my own GitHub account. I'm going to clone that to my local development machine, and that is where I'm going to write my code, run my test, and get that feature ready for production. When the feature is complete, I'll commit that, push it back to my origin, and then in order to merge it into my organization's repository, I'm going to open what's called a pull request, commonly referred to as a PR. Now, when I open this pull request, it's going to start the end-to-end process. So let's pick up with there on this slide. I've opened the pull request, and this is going to cause GitHub to send a notification to my Jenkins server indicating that a pull request was open. Jenkins is going to check out that pull request, run all my tests, build the software, and while Jenkins is building and testing that code, my friendly little squash and merge button is disabled. And instead, we have some yellow warnings indicating that we cannot merge the software because our quality checks haven't passed. Now, if that build fails for any reason, whether the code doesn't compile or a test fails, we fail to meet code coverage targets, any type of check we want to write into that Jenkins pipeline can prevent the code from being merged into our master branch. This does away with the problem of developers seeing a failed unit test and making a decision that that unit test isn't important and they're going to merge the code anyway. This enforces that process. Once the build is complete, Jenkins is going to send the results back to GitHub. Once the results are back in the GitHub, this is for a successful build, and you can see now my squash and merge button is available. At this point, another developer is going to review the code and decide whether to squash and merge. So I want to point out that this is one of the places in this continuous integration and delivery pipeline that we want human intervention. We want developers reviewing one another's code, making suggestions, and making sure that development standards are adhered to. This process lets developers interact in the ways where they're valuable and doesn't waste their time in ways that they're not, such as pushing buttons to start builds. Once the developer squashes and merges this code, that's going to send a push event to my organization, also known as my upstream. When that event occurs, GitHub is going to send another notification to my Jenkins server. And now, my Jenkins pipeline scripts or Jenkins files are written in such a way that my Jenkins server is able to differentiate between a pull request build and a master branch build. We know that commits to our master branch are intended for production. So when we have a master build, we can add additional tests. Anything you would add to a release candidate build, maybe you want to add performance test or integration or systems test. Jenkins, the same Jenkins file can be written to do additional work on that master branch. So Jenkins will build and test, and once those tests are successful, it can release to production. So one other thing that we do to enable this end-to-end closed communication loop is that for every GitHub repository that we want to operate in this manner, we configure a webhook. In the settings, you go over to webhooks, and then you'll add a publicly accessible IP address for your Jenkins server, followed by GitHub-webhook. Now, in a production environment, you could use an Nginx server as a reverse proxy to intercept that traffic and send it to your Jenkins server so that it could remain behind the firewall, or something like Traffic as a load balancer to filter your requests and send them on to Jenkins. For the purpose of the demo today, I'm going to be using a tool called ngrok, where I've configured a URL that's ngrok is then going to forward to my local host. So we've got the webhook configured, and the next, this is where we specify which events we want to receive. You can have everything sent to Jenkins, or you can specify, you really just need the push event or the pull request event. So this is how we set up the communication between the two entities. The way we lock down that branch until all tests have passed is that we make a branch protected in GitHub. Now this is typically your master branch. You go into your settings and branches, and once you select the branch that you would like to lock down, you're presented with some options. We want to protect the branch, and we want to require status checks to pass before merging. So with the webhook configuration and the protected branch, we're able to have end-to-end communication between GitHub and Jenkins and we're able to prevent code from being merged into our master branch for release until all defined quality checks have passed. So let's see what this looks like live. I am going to hop over to my development machine, which is VirtualBox running Ubuntu, because that's just where I'm most comfortable working. And I'm going to be talking about a few different technologies as I show you the solution, and we'll talk about it in more detail about how each of those technologies plays a role in the solution after the demo. The first thing I want to do is show you that I have only one Docker container running. I want you to see that I'm not already running the Jenkins container. I only have an LDAP container running. So I'm going to be showing you an integration with LDAP for user authentication. In other organizations where I've worked, we've used Active Directory. LDAP's just a lot simpler for a demo, but the mechanism is exactly the same. If your organization is using Active Directory, you can use the same solution. So I'm going to start my Jenkins server by running, can't type today, guys, running Docker Compose up. And the first thing that's going to happen is before the server itself starts, you can see some pre-configuration occurring with my GitHub credentials, Docker Hub credentials, LDAP security, and so forth. And only after that pre-configuration occurs does the Jenkins server start. So I'm just going to give this a minute until we have the indication that the Jenkins server is up and running, and then we'll go over to the Jenkins UI and I'll show you all of the configuration that has been performed the very first time this Jenkins server started. Looks like we're up and running. I've got a bookmark here. So if you've ever installed a Jenkins server for the first time, recall you install the server and the first thing you have to do is log in with the default administrator password. You have to get onto the box, either go onto the physical box or have SSH access and go into a log file and copy a long password, log into your Jenkins server, configure authentication, and then your users can start logging into Jenkins. Well, this is a brand new server, and I don't need to do any of that with this LDAP authentication. I can log in immediately with my LDAP username and password. Again, this could be your Active Directory username and password. And as soon as this new container is started, it's available to all the members of my engineering team. I'm going to walk you through all of the things that are configured the very first time this server starts, starting with that LDAP plugin. Pay close attention to this particular plugin because it's the one I'm going to use after the demo to walk you through how I pre-configured this. So in order to be able to use LDAP, we have installed an LDAP plugin, and we have just really 4 critical pieces of information that need to be configured. The LDAP server name, the root DN, the manager DN, and the manager password. Those are the 4 pieces of information that allow me to log in immediately. Now the next thing I've pre-configured is the matrix-based security plugin. Typically you would configure this to give very granular permissions to different users and groups, but I've, for the sake of this demo, given administrative privileges to my user. So this allows me to log in immediately by authenticating with my LDAP server. Now I'm going to need some credential sets to interact with third parties. Out of the box, I've got 2 different GitHub credential sets. I've got my SSH key, which is what I use for checking code out from GitHub. I've got the GitHub personal access token, which is used for interacting with the GitHub API, which is a requirement of a couple of plugins. I've got Docker Hub credential set set up, which is going to allow me to pull from and push to a private Docker registry, a Slack integration token, and also an SSH credential set, which will allow my Jenkins master to communicate with my Jenkins agents. Next, I'm going to show you that we've got the global pipeline library configuration already set up. My Jenkins files each specify a global library to use and use methods from that global library. And typically, you're going to have to go into your system settings and configure that library, but with this solution, this is going to be configured automatically as soon as the server starts. Scroll down to that piece. I've got the name of the owner of that. That's the GitHub owner, which is my organization. The credential set I need to interact with that organization, and then the name of the repository. I can also specify an alternate name by which to refer to this library for my Jenkins file. I've used the same name, and each of my Jenkins files is going to access the library by that name. I don't have to configure anything. My Jenkins files will work automatically as soon as the server is started. The next thing I want to show you is that I have my Docker host configured. This plugin can be used to configure any type of Docker host. In this environment, I'm using my local Docker socket. So the Docker host running on my Ubuntu virtual machine is made available to my Jenkins container running on that host so that Jenkins can use it to build and push additional Docker images. I've also configured 2 different custom Docker agent templates. I've got a base Jenkins agent that's used for general building of Docker images and pushing those, and then I've also got a .NET Jenkins agent that I've used for building a couple of .NET Core APIs. So as soon as this Jenkins server is available, I can already run my Jenkins files. I can refer to my custom Docker images by name, and those builds will occur on Docker containers built from those custom images. So the last thing I want to show you is my favorite plugin, is the GitHub organization plugin, and I believe this functionality has been pulled into a different plugin in a recent release. Let me show you how that's pre-configured, and then I'll show you what it can do. When my Jenkins server loads, I have all of my GitHub organization information already configured, my name of the organization and the credential sets, which use the personal access token for interacting with that organization. I specify that I want to discover all the branches for the repositories in that organization, and the most important piece is I want to discover pull requests from user forks. Now when I push this save button, this is going to scan the dev Mandy organization. It's going to look at all the repositories, and it's going to look for a Jenkins file. You can see here that Jenkins file was not found in this repository, but I do have one repository for the demo here that does have a Jenkins file. I'm going to stop this because I want to show you the pull request. So I've got one repository with a Jenkins file for this demo, but you can imagine how many repositories does a large organization have with a Jenkins file. Instead of going and having to create a brand new pipeline job for every single one of those repositories, this plugin allows Jenkins to scan that organization and discover those repositories and automatically create those jobs. Now remember in the slide deck we talked about how opening a pull request started that end-to-end communication. I want to show you that as well. I've got a pull request. I got everything set up that I'm just going to click pull request, create pull request. I'm logged in here with my developer account, and you can see that I want to merge into my organization's account, the master branch, code from my developer user fork, just like in the diagram. So I'm going to create this in GitHub and then hop back over to my development machine. And we've got the quality checks haven't passed, so we don't have a squash and merge button. And then over in Jenkins, you can see GitHub notified Jenkins of this pull request. Jenkins has checked this out locally and is building and testing that pull request. And just as I showed you in the slide deck, GitHub is going to be locked down while that build is occurring. So Jenkins knows this is a pull request. It's going to run the test and build. It's going to build the Docker image because that's part of testing that the pull request is successful. The Docker file is code as well. Everything is successful, and Jenkins has sent a notification back to GitHub. I can now squash and merge, well, another developer would squash and merge this pull request. Once we return to Jenkins, you can see that Jenkins is now building the master branch. This pipeline script is written in a way that Jenkins knows this is the master branch. This is where you would add additional tests. You might want to push this first to staging to run some additional tests and then push to production. You can do all sorts of things with your Jenkins file to customize it for your organization's process. But the point here is that Jenkins knows this is the master branch that we wish to push to production. So you can see here, in addition to building the Docker image, we're pushing it to Docker Hub. It's been tagged with a symbol, and we're pushing it to Docker Hub. And then we have this last step to deploy to production. Sorry, let me get this dialog. This is one of the other pieces of intentional manual intervention. As I said, I developed this solution for a company that was subject to a lot of regulations. One of those for PCI compliance is that only specific people were authorized to deploy code to production. And this dialog box allows us to build the code and get it ready, but not actually deploy it until an authorized person comes and clicks the OK button. Now, if someone came through that did not have authorization and clicked this OK button, then we wouldn't actually be able to push to production. It would fail. So that's, again, one of the purposeful manual steps that we have in our Jenkins pipeline to allow us to be compliant. So, let me make this full screen. Sorry, I can't find my, oh, this is the way. My presentation dialog is in front of my PowerPoint dialog. So, do you see what we did here? We built a Jenkins platform that is definitely indispensable, but also it's completely disposable. It's really cool, right? The best thing about the solution is that developers really like using it. Everyone on the team agrees on it because it's very easy to use and it gets rid of a lot of manual steps, and it's reliable. Developers love that there is a check in place that is going to be guaranteed to run all tests before we even attempt to merge it into our master branch. We aren't forcing tools and processes on people. We are changing the culture, which is at the very heart of DevOps. When a team believes in the continuous delivery process, it's easy to get them to follow it. Jenkins is doing this, and Jenkins is critical to our way of life. It's so critical that we can't afford to lose it, even for a few hours, not to mention the time it would take if we were to have to rebuild this entire monster. It's indispensable. But I've automated the installation and configuration of plugins and the creation of credential sets and jobs, so everything required to set up a new Jenkins environment is stored in source control, version, and released just like any other software. Let me show you how I've also made Jenkins disposable. So I'm going to talk you through the technology used to develop this solution. And of course, in addition to Jenkins itself, we're running Jenkins in a Docker container. I'm sure that many of you are also running Jenkins in a Docker container, but for those of you who might not be familiar with Docker, it's a containerization platform. And this allows us to package Jenkins in a very portable way that allows us to run it in the exact same environment regardless of the Docker host we choose. I'm running this on my Docker host on my local laptop here, but we could also deploy this to any cloud provider, or you could run it in your own environment, in your own organization. I'm going to talk a lot about a tool called Container Pilot. Container Pilot is an implementation of the autopilot pattern. Containerized applications that implement the autopilot pattern are responsible for understanding their own startup and shutdown, their scaling, their ability to recover from failure. They're smart enough to reliably and accurately bootstrap themselves and configure themselves for operation with no human intervention. They are completely automated. Container Pilot is Joyent's implementation of the autopilot pattern. It's a helper application that runs inside your Docker container to facilitate the autopilot behavior. This is really useful for taking existing applications that weren't written according to this pattern and allowing them to inherit the autopilot behavior. Container Pilot is going to act as a supervisor process that monitors the application, in this case our Jenkins server. It registers it with a service catalog, in our case console. It performs health checks, and the most important part is it runs user-specified code at events in the life cycle of this container. For example, we can specify an action to be performed before our Jenkins application starts and before and after it stops. So this life cycle management feature is the one that allows us to pre-configure our Jenkins container before the Jenkins server itself is actually started by specifying a script to be run at the pre-start event. And the reason this is important is because there is quite a lot of automated configuration that has to happen every time we bring up a new container. And by tying this automation to the pre-start lifecycle event in Container Pilot, we can ensure that the process is reliable and repeatable. The next piece is Console, which is a service discovery application. For this demo, I scaled down the application cluster to just Jenkins and Console, but in a production Jenkins environment, you might also have other services, such as Vault for managing secrets, or Traffic as your reverse proxy and load balancing. Additionally, it is a dependency to run Container Pilot, so it is also a part of this particular demo for that purpose. And then the last piece is Docker Compose. Docker Compose is a tool that allows us to define and run multi-container Docker applications, and it configures the services using a compose file, which I'll show you in a moment. So when the container starts, there are two processes running. There's our main process, which is Container Pilot, and then there's a console agent that runs on the Jenkins container. At this point in time, we are in the pre-start portion of the life cycle of this container. Once the pre-start event defined in the config file has completed, and only once it's completed successfully, does Container Pilot start our main application, which is our Jenkins server. Additionally, we can schedule periodic health checks and also tasks, sort of like you would with cron jobs. These health checks are really interesting because it can allow you to probe the Jenkins server either through the Jenkins API or hitting a URL directly to kind of test out the health of Jenkins itself and not just rely on whether or not the entire container is still running. The next piece is Docker Compose. So Docker Compose allows us to codify all of the commands we would include with the Docker run command. We've specified the image we want to run. We've specified the local Docker socket should be mounted. But the two most important pieces for this particular solution is we're able to specify a file for Docker Compose to use to read values and inject them at runtime into the environment of this running container. And I'll show you what that file looks like in a moment. And I just want to point out that the command we run is actually Container Pilot itself, and then we simply pass the Jenkins startup script as an argument to that main command, Container Pilot. So that's our Docker Compose file, and it really allows us, again, as I said, to codify these commands, these switches, so that every single time we run our Jenkins container, it's guaranteed to run the exact same way every single time, as long as we're running the same version of our Docker Compose file. Again, it is also versioned and software defined just like any other piece of code. So I want to walk you through how we pre-configure this, and I'm going to do it in the context of a plugin. So just for the sake of making sure everyone's on the same page, I want to talk about how plugins work. Typically, once you've installed a plugin, you log into the Jenkins UI and you enter the data you want to configure that plugin. And that data is written to a simple XML file. If you look in your Jenkins home directory, you'll find a lot of different XML files. For this plugin, it's the config XML file. So you enter the data through the UI and it's written to the XML file, and then when your plugin loads, it reads the data from that XML file. So configuring plugins is just a matter of modifying the correct XML file. With the LDAP plugin, we have those 4 pieces of information that we enter through the UI: the server, the root DN, the manager DN, and the manager password. I need to get those 4 pieces of information into the correct XML file, and I don't want to use the UI to get that information. So where can I get that? Quickly, just to show you what that XML file looks like, you can see here I've got server root DN, manager DN, and manager password secret. So I need to get that data somehow, and I need to put it into this particular XML file. And that's where the Docker Compose environment file comes in. I can specify a number of different pieces of information that are injected at runtime, and here I've specified all the information I need to configure my LDAP plugin. So I've identified the pieces in that XML file, and I've got these available by injecting them with Docker Compose, which results in the Jenkins container having these values stored in the specified environment variables at runtime. So I've got the XML file, I've got the values that I need in environment variables. The next piece is, this is a snippet from the script I run during the pre-start event. This is just a shell script that runs, and this is the method that actually modifies the LDAP plugin. It simply finds the XPath for the 4 pieces that I need to modify, and it substitutes the default values with values from the specified environment variables, which I've highlighted. So again, we've identified the XML file, we've gotten the data into environment variables, and we read the data from environment variables and substitute them into the proper XML file. The last piece is just, we've configured container pilot so that when the container starts, we actually, this is what actually runs that pre-start script to give us that end-to-end configuration for that particular plugin. And this is how we run all of our plugins. So, why did we do this? What is the point? What does the business want? The business always wants to go faster. They're always asking us to go faster, faster, faster. And we implement various tools. We use Agile and DevOps practices, all in the interest of making the business go faster, but it's quality and continuous integration and delivery that help ensure that we're doing that safely. And Jenkins is how we achieve quality. Now, in order to create this completely automated delivery pipeline, I've utilized some of Jenkins' advanced capabilities pretty fully. But the thing I want you to understand is that Jenkins is just software. Roll up your sleeves and get in there. Look through the home directory. Understand how your plugins work. You'll see that Jenkins is even more versatile than you even knew. This Jenkins server is critical. It took me weeks to perfect it, and I can't afford to repeat this if something goes wrong. But your Jenkins server is critical too. Even if you don't yet have a full continuous delivery pipeline built out, I'm certain that whatever functions your Jenkins server is providing right now are critical to your team as well. So the more automation we add, the more dependent we become on Jenkins, the greater the risk of allowing Jenkins itself to become the single point of failure. Now, the only way to remove that risk is to make Jenkins itself disposable. Remember the nightmare scenario we started with at the beginning of the session where the Jenkins server crashes? If that happens on my team, we're good. Our world keeps moving and we sleep just fine at night. By building a Jenkins environment that's both indispensable and completely disposable, you can too. I'd like to open up for questions. I wanted to give you my contact information. Feel free to reach out if you have any questions that we don't get to today. And I'll also show you some additional resources in a moment here. Sorry. Where you can find information about this particular solution. The first is a sample implementation that Joyent provided using the autopilot pattern. This was the starting point for my solution. It's a great starting point for you as well. And I've detailed some of the information I spoke about today in these two blogs. All right, Max, I'll turn it back over to you.
Sure, so I'm actually going to pass it over to Andrew, who's on the line, who's been watching the questions come in. Andrew, what have you seen?
Well, first there were questions about whether this will be shared and where to find it, but the recording, the slide deck, and the Jenkins files using the demo.
Absolutely. So I'm collecting everything, and the series that we're in right now is going on now through Thursday. So after everything, we'll have it all loaded up. We'll make one nice simple email for everyone, and you'll all receive it either Friday or Monday should be.
All right, then some more technical questions. What exactly is the role of console in this whole setup?
So in this setup, console is a dependency of Container Pilot. You can't actually run Container Pilot without actually running the console agent and using a console server. That's why I included it in the demo. It has a much larger purpose in a production environment where you want to interact with other services. As I said, if you want to use traffic as a load balancer or a reverse proxy to make that Jenkins server publicly accessible, or if you want to keep your secrets in, you can keep secrets in a tool called Vault. Console also has a key value store that you can use. But for this demo, it simply is a dependency of Container Pilot.
All right. How does this solution handle the maintenance of logs and artifacts? Those things are not disposable, especially under certain regulatory requirements.
That's a great question. I've sort of started exploring that myself. A really good approach is to use a third-party artifact repository, such as Artifactory or Nexus. I know that Jenkins has some excellent plugins for Artifactory so that you can build all of that into your pipeline as well and make that completely automated in addition to the building of your application.
Do you do automated agent provisioning? If so, how do you do it?
I do automated agent provisioning. If you'll recall in the demo when I showed the system settings and we had the local Docker host and specified some templates to use for your Docker agents, then in the Jenkins file itself, you simply specify the label you gave to that agent, and it's going to provision a Docker container to build that Jenkins file, and then when the build is complete, it will dispose of that Docker container, so it's alive just for the lifetime of your actual build. This also keeps a really clean build environment since you're guaranteed to build with the exact same stack every single time without anything left over from previous builds. Anything else?
Trying to find other questions that are useful. How fast and easy is it to provision and configure an agent on demand?
It's pretty quick. It's also going to depend on your Docker host, or if you're using a Docker swarm, or what type of environment you've got behind that particular running your Docker. For this demo, I actually, instead of provisioning a whole agent to run everything on, I use the in-container feature just to run an existing Docker image because it's faster for demo purposes. It will take a little bit longer to start your Docker container, Another option, I believe it's in experimental mode, is there is an option to keep a Docker container online as long as possible so that the same container is reused. So you can either use an ephemeral Docker container as your build agent, or you can also experiment with reusing the same Docker agent so you only incur the cost of creating that container initially a lot less frequently.
Maybe I missed it, but is the Jenkins server always running in this scenario, as opposed to just the Jenkins agents being disposable?
The Jenkins server, so the Jenkins server is always running. The part that makes it disposable is that if something happens and we need to restart or rebuild Jenkins, that everything is pre-configured. We typically, in environments where I've used this solution, we typically don't start a new container for months at a time. This is a disaster recovery scenario more than a situation where we will actually restart the Jenkins container daily. As long as you have a way to keep your artifacts, you can feel free to start a new container as frequently as you want. But the main concern here is that if we had to start a new container, we could be building our software very quickly, and our development teams and our releases wouldn't suffer downtime. But it does continue to run until we choose to shut it down, unlike the agents where, at least in my configuration, they run only long enough to complete the build.
Is the authorization validation for deployment to prod done by a global library? If so, are you just matching against a predetermined user list or group?
Do you mean with, I'm assuming you mean with the dialog. That is configured in the plugin. You can match against a user or a group, either one. But they must be authenticated into the Jenkins UI before they would be able to authorize that deployment as that user.
How would you deal with too many agents being requested, exhausting the Docker node's resources?
Well, that's going to come down to a scalability issue where it's just like you would manage any type of Docker environment by using orchestration tools. There are several different plugins, and you can integrate this with various cloud providers with unlimited resources. You can use this with Kubernetes and Docker Swarm. So it really comes down to more of a question of managing a Docker environment than managing a Jenkins environment. It doesn't really become unique to Jenkins at that point. It's just how you would manage any other Docker deployment.
How are all the jobs repopulated after the environment is brought back up?
So the jobs are repopulated. Let me show you my GitHub repository just to make sure that's clear. So this is my GitHub repository that was detected, and I have here a Jenkins file in that repository. And when the GitHub organization plugin scans this repository and sees the file, the Jenkins file, it automatically creates that job on the fly. And anytime you rescan the organization, it's going to repopulate those jobs.
When new versions of Jenkins are released, how much time does it take to update your container?
It's just a matter of building a new image. Let me show you. I simply have to go in and update the Jenkins version and rebuild the image, update the version in my Docker Compose file, and then do a Docker Compose up, and I've got the latest version of Jenkins. The interesting thing about that solution, though, is I've heard other users talk about having problems with plugin versions and Jenkins versions. I like that I can leave my production Jenkins server where it is, make those changes to the Docker file and the Docker Compose file, and bring up a new Jenkins container that's going to be identical to the one I'll run in production, but I can take the time to test and certify and make sure I'm comfortable with all of the changes involved in that upgrade.
Is it possible to Dockerize this Jenkins pipeline, which will in turn create containers and then spin them down as necessary?
It is Dockerized. That is what happens in the pipeline. It creates the containers to build the application and then spins them down when it's done. You can create your pipeline to spin up a container to run your application and do integration or system level testing against a running application. There are a lot of things you can do with Docker containers in your pipeline, but this one does in fact spin them up and then spin them back down, as you said.
Is historical job data maintained in case Jenkins needs to be disposed of and reprovisioned again?
No, we touched on that briefly about using a third-party tool for storing artifacts. They're great plugins for Artifactory, and Nexus has a free version. We can back this data up on premises if you want to maintain historical data.
How would you use this strategy? How would you use this strategy when your build needs to run on OS X, say building for iOS? Is it applicable?
Yes, it should be applicable. Well, let me take a step back. I'm not familiar with running Docker containers to build applications for OS X, so I can't really speak to that. If you can run an OS X Docker container, which, again, I'm not certain that you can do that, then you could use it for that. Yeah, okay. There's your answer. Docker and OS X aren't compatible, but you could still run Jenkins in this Docker container. You just couldn't spin up. You have to use a physical agent as your Jenkins agent, so you would want to set up an OS X physical agent, and you could still, though, pre-configure that ability to interact with that agent so that your builds would run. So the only thing that really prevents it is the ephemeral Docker agents. So one other question that I've gotten before, in case any of you were wondering and didn't actually enter it, is the use of environment variables in the Jenkins UI. It's been asked, what about the fact that any user who logs into Jenkins can go and view the environment variables in the UI? The solution to that, which I haven't yet implemented, is once your plugins are configured, you don't need access to those values anymore, and you can clear them out of the environment variables so that they're not visible in the UI. So that's one option that you can do there. You can also read them from some sort of secret management solution, such as Vault. There are other ways to manage your secrets. If that's not something that works for your organization, there are a lot of other ways to manage those.
What is the best resource, in your opinion, for learning how to automate releases with Jenkins?
The best resource, in my opinion, for learning to automate releases in Jenkins? That's a great question. Honestly, the cloud-based documentation is great. You can, the internet is full of so many blogs and tutorials, documentation to set up your first pipeline script. I know that a couple of the online education providers have courses. I'm actually in the process of developing kind of a continuous delivery best practices with Jenkins course for a particular organization that should be available in the spring. There really are a lot of resources out there, but I would just start with writing something simple. I mean, it's just like any other code. You can start with a hello world and get that to work, and then write your pipeline so that you can check out from a repository, and just kind of iterate, adding additional small steps until you have a working application. And I'm absolutely available to help guide you to some great resources offline if you contact me. I'm happy to do that.
Thanks, Mandy. Everyone, I'm gonna put Mandy's Twitter handle once again back into the chat window, just so you all have it in case you like to reach out to her, as she just mentioned. The questions have really slowed down, and we are just about, there are a few, but we're just about at the end, and that some of them are a bit longer answers. So I think we're going to be wrapping it up just about now. So I just want to thank everyone again for joining us. Again, if we didn't get to you, I am collecting these questions and taking them offline, and I'm also going to put my email here in the chat window, so that if you have anything that you want to ask that we didn't get to or didn't have time for, please email it to me, and I'll make sure everyone sees it. So I just want to say thank you to everyone who joined us. We do have more webinars coming up in this series. If you are going to be partaking in any of them, you can just use the same join link that you used for this one and also for the previous one if you were there. We'll be getting the recording and the slides to you all later this week, possibly the start of next week. And thanks again. I hope to talk to you all again real soon. Thanks, Mandy, for the presentation.
Thank you for having me.